Okay, guys, so I want to go over 3.4 polynomial functions, and we are specifically talking about the graphs. And before I talk about polynomial functions and how they behave, I want to talk about power functions. Okay, a power function is of the form f of x equals ax to the n. So a few of them, for example, a very simple one is, of course, f of x equal to x. Now, of course, that is your simplest one. Okay, we know that just goes like this. And the thing I want you to notice is how it's beginning at the left and ending to the right. Okay. Another one that we can think of, probably the next simplest, is this one. I know you've seen this one before. This one is f of x is equal to x squared. And in this case, I want you to notice how it begins and how it ends. Okay. Let's keep looking at a few of these. Naturally, I'm going to go to the next power, and we've actually seen this function before as well. F of x equals x cubed. Okay. If you recall, that one looks something like this. Okay. Once again, it starts like this, down low, ends high. And I don't know if you've seen this one before, but this is f of x equals x to the fourth, which does a similar thing as x squared. You can try plugging in some points, but basically it's something that's just going up generally faster than x squared, okay? And once again, 4 is a little messed up. Once again, realize how it begins and how it ends. And I could keep going, okay? Now, the thing I want you to notice here, okay, is that this first one, that's like f of x equals x to the first power. Notice that whenever it's to an odd power, like x to the 1 or x cubed, it starts low and it ends high, okay? You could say as x approaches negative infinity, f of x, the function value, approaches negative infinity, right? And as you approach infinity, f of x, the function value, approaches positive infinity. That's for these guys. Now notice with these, when we have the even powers, it's a little different. It starts high and it ends high. Starts high and it ends high. Okay, so it's a little bit different than when it's odd. And if I were to graph x to the fifth, it has that same sort of end behavior. That's just something we can tell what's happening at the very large negative and very large positive values. Okay. So let's switch it up a little bit. I'm not too concerned in our power function about what a is. If it's a 2 or 3, we know that stretches or shrinks. But what I am concerned about is if it's positive or negative. So let's suppose I look at f of x equals negative x, this one right here, okay? Now we know that goes like this. And what I want you to notice is instead of starting high or starting low and ending high, now it's starting high and ending low. It just completely flip-flopped. Well, that makes sense because throwing the negative in front, that is a reflection over the x-axis. So it just changes this end behavior. Likewise, if I look at f of x equals negative x squared, we've seen that before. We know that also gets reflected over the y-axis. Okay, so that'll start low and it'll end low. So the negative, it basically just flips the end behavior, okay? So this is the first thing I want to talk about. So with power functions, we can see what happens with the end behavior. So what does that tell us about polynomial functions, right? Well, let's look at a polynomial function, okay? Polynomial, okay? If I have something like this, f of x equals negative 4x to the fifth plus 2x minus 1, okay? Well, as x gets very large, okay, so let's look at this graph. As x gets very large, or as x gets very large negative, right? So as we go really far this way or this way, think about what term is kind of taking over, which one's most relevant. It's definitely this one with the highest degree. As x gets very large, these are almost negligible. And that's true with any polynomial function. function. So that tells us what's happening at the endpoints. So essentially what I'm saying is these polynomial functions have the same end behavior as the power functions associated with their leading term. So if I look at this, I see, well, this is odd, okay? This first coefficient in front is negative. So I would venture a guess that this thing is going to start high and it's going to end low in the long run, okay? What if I try a different one? What if I looked at something like f of x equals 2x to the 8th plus 3x squared plus 5x, something like that, okay? Well, this is even, this is positive, so I'm expecting something that is going to start high and is going to end high. Okay, so this is really the first thing I want to look at for polynomial functions is this sort of end behavior, and they go through it in the book as well. So I encourage you to read that.